Induced charge. We'll start off with some video clips. Here's a can, and we're going to hold a neutral charged wand towards it. It has no reaction, but once I charge the wand with rubbing it with some rabbit fur, now the can is attracted to the wand. Right, we have a neutral object acting like it has a charge. It's attracting the positively charged wand. We can also use the same concept to explain how an electroscope works. When I hold the positive charge wand towards the electroscope, the legs move apart from each other. The electroscope is a neutral object and it's acting as if it has a charge. It's repelling. The legs are repelling each other. Conversely, when I hold the negative charge wand up to the electroscope, the legs move apart from each other. Again, the electroscope is a neutral object, but it's acting like it has a charge. The legs are repelling each other. So in explaining this, for an induced charge is what we call this, a neutral object is acting like it has a charge on it. Right? This only occurs in conductors, not in insulators. Insulators has a different term that goes along with it. So here's my animation. We're going to take my rod and rub it with some rabbit fur. And the fur is removing electrons, so the rod ends up with a positive charge to it. And we hold it up to the electroscope, and the electrons, the free electrons in the conductor, are allowed to move around, and they're going to be attracted up to the top near the positive charge wand. This leaves positive charges in the legs, and those like charges repel each other. Notice that the net charge on the electroscope is still 0. It has the same number of pluses and minuses. The opposite wand, if we rub it with silk, we end up with a negative charge on the wand. When we hold it up to the electroscope, the negative charges in the wand are going to repel the electrons. They're going to try to get as far away as possible from the electric field up here, leaving positive charges in the top. And these electrons down in the legs are going to repel each other. In both cases, the net charge on the electroscope is 0. There's no touching and there's no transfer of electrons. This is called inducing a charge. We're making a neutral conductor attract or repel. It's acting like it has a charge on it. For the soda can, when we move the rod over next to the soda can, you can see that the free electrons are attracted over towards the rod and they move to one side of the can. That way the can attract towards a positive charge object. Or if we stuck a negative charge object over here, the negatives would repel away from the negative charges.